So we are going to split this one into 2 days, so don't panic. We're not doing all of these today. Okay? I'm going to kind of pick and choose as I go. Let's see how far did we make it on this. All right, do we have that essential question written down? Okay, and that's going. All right. So we're supposed to, we're going to learn how to simplify expressions and solve equations that contain sums or differences of angles. Okay? All right. Do you have to fill that stuff in? Okay, so I'm going to give you a couple of minutes. Go ahead and fill that stuff in. I think that... you only have to fill in the right side. Okay? The left side, they're torn apart for you. The right side, you have to fill in. Okay, so fill in the right side. That's typically how, the right side is typically how they look in a book. Okay, and I'm going to look at this one quick time here. Really make sure you're writing the signs exactly the way that it looks. Huh? One of them does. The one that's plugged in works. Okay. All right, we got them written? All right. Okay. The reason I've been waiting on this one. Okay? So, what we're going to look at is we're going to look at, I said you didn't have to memorize them, but the first two, it's so easy to memorize. Okay? I do something that's going to make you remember this. Okay? So we're going to focus in on these two. The big difference is we have, when you start with the sign, okay, it goes plus, minus, and when you start with the cosine, it goes minus, plus. Okay, so if you start with the plus, you use the minus. If you start with the minus, you use the plus. Okay? All right. So we're going to all stand up. Stand up. Trust me. Okay? Stand up. Okay? See if I can remember how to do it. Okay? Normally I do it the other way. No, on the floor, not on the chair. I'm standing on the chair so you can see me. Okay? Hopefully I don't fall off the chair. All right, you ready? Okay, so we're going to do a chant. Okay? So we can remember these things. All right? You ready? Okay, so we're only going to look at these parts here. Okay? So it goes sine, cosine, cosine, sine. Alrighty? So let's repeat that. I'm going to do it one more time and you're going to repeat it. You ready? Okay? Sine, cosine, cosine, sine. Alright, now you do it with me. Ready? Sine, cosine, cosine, sine. Alright, one more time together. Ready? Sine, cosine, cosine, sine. Alright, then the next part goes cosine, cosine, sine, sine. Alright? Alright? So the next one, I'll do it one more time. Cosine, cosine, sine, sine. Alright, so do that part with me. Cosine, cosine, sine, sine. Alright, one more time together. Cosine, cosine, sine, sine. Alright, now we're going to do the whole thing together. So I'm going to do it once, or else I'll do it twice, and you guys do it with me, okay? Alright, so it goes sine, cosine, cosine, sine, cosine, cosine, sine, sine. Alright, I'll do it one more time. Okay? Sine, cosine, cosine, sine, cosine, cosine, sine, sine. Alright, let's do it together. You ready? I'm going to do it on the count of 3. 1, 2, 3. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. I didn't see you all head bobbing.
Oh my God.
Okay? All right, I can't point, so we're gonna head bob at the same time. So we're gonna all do it together. You ready? Okay? All right, I'm watching to make sure everybody does it. Okay? This is how you really remember it. All right? So on the count of 3, ready? All right, 1, 2, 3. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. All right, gotta do it sideways. Okay, sideways head bob. All right, one more time with the head bob. Okay? Ready? You see why I didn't want you to miss this day? All right. Because you won't forget this. Okay? All right. On the count of 3. 1, 2, 3. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. All right, sit down. All right.
I think we need to do it
Best
again.
day of math analysis. You got to watch Mrs. Ballard head bob. Okay. That's as much as I can dance, okay? I don't know where my children got their dancing ability from. So, and it wasn't my husband. Okay, you won't forget it, I promise. When I first found that, my 5-year-old was a baby, and we were doing that. I would sing that to him. So, I don't know. He loved it. He loved it. Okay. All right. So let's take a look at this. We're going to find the exact value of the expression. Okay. We're going to use that sum and difference formula. If it's on the test, we're going to break this up for you. Okay. What we're going to do is try to find something that we know, which is on the unit circle, so we can evaluate it. Okay. Because exact value means we want to be able to evaluate it. Okay. So I'm going to choose to break that up into cosine of 30 plus 45. And it wouldn't matter what order, okay? All right, so here's where the chant comes in, okay? Because I don't have to look this one up very much because I know the chant, okay? So it was sine, cosine, cosine, sine. And that's what it went with the sine, right? Sine, cosine, cosine, sine goes with sine. Cosine, cosine, sine, sine goes with cosine. All right, so what am I going to use for cosine? Cosine, cosine, sine, sine, right? So cosine, cosine, sine, sine. All right, and then with cosine, is the sign the same to begin with or opposite to begin with? Opposite. With sine, it's the same. With cosine, it's opposite. So I'm going to use the opposite sign. So it was a plus sign, so I'm going to use a minus sign. Then all I do is I drop these two angle measures in. So I drop in 30 and 45 and 30 and 45. I know what those are. I can evaluate those using the unit circle. Okay, so you have the book out in front of you, right? It has the unit circle there, so you can look it up. All right, so help me with that looking it up. So what is the cosine of 30?
Let me check.
Everybody can be looking, not just Ivan.
Square root of 3 over 2.
Square root of 3 over 2. Good. What's the cosine of 45? Yeah, square root of 2 over 2. We're used to doing radian measures so much that we've kind of forgotten some of the angle measures. All right, what about sine of 30? Sine of 30. 1/2. Good. Okay, sine of 45. Square root of 2 over 2. Good. Okay.
Unit circle, come on.
Unit circle. All right. All right. Okay. I'm really glad that hasn't happened in years where we've gotten on somebody that it's the unit circle. That was awesome. Thank you. All right. So let's go ahead. We're going to multiply across the top. What is square root of 3 times square root of 2? Square root of what? It's 3 times 2, guys. 6. There we go. Okay. Remember, it's not coming out to be nice square numbers. You're just going to keep the number underneath the radical sign. All right, 2 times 2. 4. All right, and then this other one would end up being square root of 2 over what? 4. That's a great answer. They might write the answer square root of 6 minus square root of 2. Remember, I cannot put these two together because they are not like terms. It's like having x minus y. We can't put them together. Okay? If it was square root of 6 and square root of 6, then we would combine the coefficients in front. Okay? All right. The nice thing, so that one they didn't break it up for us. If you have to break one up, try to get things that are on the unit circle. Okay? That's going to be your easiest bet. Okay? This one, they were nice and broke it up for us. All right, so this is sine. So what was the sine part of the chant? There you go. And see how I just wrote the initials and then I go back and fill in my sine, cosine, cosine, sine part? All right. With sine, is the operational symbol in there the same or opposite? The same. So I'm going to use a minus. And I'm going to plop those radian measures in there. The radians work just like the degrees. Okay. Lauren's going to be so mad that she was absent today. This was the best day of the year. All right. It's her fault. Okay. All right. So what is the sine of 7 pi over 6? Use your unit circle. Everybody should be looking it up. 7 pi over 6.
7 pi over 6.
Should be negative 1/2. Okay. All right. What is the cosine of pi over 3? 1/2. Good. Okay. What is the cosine of 7 pi over 6?
Negative 1/2.
Good. Okay. What is the sine of pi over 3? Good. Square root of 3 over 2. All right. Again, it's all of that was reading the unit circle. Now we're going to do some arithmetic. Okay. So it's negative 1/2 times 1/2. Negative 1/4. Good. Negative square root of 3 times square root of 3 is just what? Negative 3 over what? 4. Double negative is going to go? Positive. So 1/4, negative 1/4 plus 3/4 is? 2/4, better known as 1/2. So all it is we applied a new formula. We plugged the radian measures in. We found the radian measures off the unit circle, and we did some arithmetic. Okay? All right. So on this one right here, let's see what we're doing. Cosine. Okay. Does this one have a lot of space? Yeah, okay. What we're going to do, I'm not going to do example 4. Okay, so if you need more space for this one, you can use the space for example 4. It's on the other page though, isn't it? Yeah. Okay. What we have to find sine, cosine, and tangent of this one. If I do one of these, that's going to be plenty. Okay? So if you need to do maybe the tangent under example 4, then we can do the tangent under example 4. Okay? So I'm going to start with the sine. They broke it up nicely for me, didn't they? Okay? What we're really finding, though, the notation we would write is the 17 pi over 12. But we know it breaks into 7 pi over 6 plus pi over 4. So I'm going to start with the sine right now. So I'm focusing on the sine. All right. So if I'm doing sine and I'm doing my little chant, okay, what is my chant for sine? Okay. So sine, cosine, cosine, sine. So we all know when Robert starts shaking his head during the test, what problem he's on. Okay? All right. What operational symbol do we start with? Add, because it's sine, we keep it, right? All right. And then I'm going to plop in the 7 pi over 6 and the pi over 4 and the 7 pi over 6 and the pi over 4. So no different than what we really did on the last 2 examples. Okay? All right. So now we're going to go ahead and we're going to read from our unit circle all those values. So what is the sine of 7 pi over 6? Negative 1/2. Good. All right. What is the cosine of pi over 4?
Square root of 2 over 2.
Square root of 2 over 2. What is the cosine of 7 pi over 6? Good. What is the sine of pi over 4?
Square root of 2 over 2.
Good. Okay. See why unit circle is very important. We got to know all these numbers, right? Okay, what did you get when you multiply these first 2 together? Negative square root of 2 over 4. Notice what I'm doing. Isn't this going to be a common denominator? Yeah, so I'm not going to worry. I'm going to make it all over one denominator. What is negative square root of 3 times positive square root of 2? Negative square root of 6. And if you notice how a lot of the answers have similar numbers in them, Yeah, we're getting a lot of square root of 2s, a lot of square root of 6s, a lot of square root of 3s, a lot of 4s in the denominator. Okay? All right. So I'm not done with that example because I haven't found the cosine and the tangent yet. I'm going to go to the next screen. Okay, hopefully you at least have enough room for cosine left, right? So now I'm going to do the cosine. So we're going to do cosine of the 17 pi over 12. That's the notation we're going to write, but we're going to use these two angles to plop in. All right, what's the cosine part of the chant? Cosine, cosine, sine, sine. So cosine, cosine. You got to bob your head, yeah. All right. For the cosine, do I keep the operational symbol or do I change it to the opposite? Change it to the opposite, and then I'm going to plop in the 7 pi over 6 and the pi over 4, and the 7 pi over 6 and the pi over 4. All right, I'm going to give you a minute. I want you guys all to read your own unit circles and see if you can get it evaluated from there. Yeah. So on cosine, it was on the sine. See how it says plus, plus on the top, minus, minus on the bottom. So that stays the same. This one goes opposite. Okay, so sine stays the same, cosine goes opposite. Okay. All right, so everybody's trying to evaluate this on their own right now, without your neighbor's help.
Yeah.
Ivan, where's your notebook? Share the book. Working it out.
It's right here.
Okay, share the book. Share the book with Robert, please.
Don't help me.
Are you a middle child? Right now, my middle child is the one that won't share. Look, you got your own.
Mine's red.
Okay, let's take a look. So what do you get? What'd you get for cosine of 7 pi over 6? Good. What about cosine of pi over 4? Square. Good. All right. What about sine of 7 pi over 6? Negative 1/2, and sine of pi over 4? Good. What's your denominator again? It's all going to be, if we're doing unit circles, shouldn't it always be over 4? Because it's always 2's in the denominator, with the exception of it being on those quadrant angles, right? If it was on the quadrant angles, we wouldn't get 2. All right, what'd you get for the first one? Negative square root of 6 minus negative what? Square root of 2, so double negative goes. So almost the same answer we had last time, but the signs are different, and these guys are in a different order. So don't just assume your answer. Make sure that you really have it right, because things change up in the order, so it's a slightly different number. All right, we haven't touched tangent. I don't have a fancy chant for tangent. I'm sorry. Okay? All right. So you can make one up, great. All right, so we've got tangent of 17 pi over 12. Okay? So I want you, let's go back and look at that tangent formula together. Okay? So here's the I'm going to look back at this tangent formula here. So if I look, now if I notice, so here's some patterns about it. I have tangent plus tangent on the top, or whatever the sign is. I keep the sign on the top, and it looks like I change the sign on the bottom. So I do 1 and the opposite sign and then tangent times tangent. Okay? So I notice it's U and V. That means the two angles. So the two angles are going to change up there. All right, so on the top, we keep the sign. On the bottom, we change the sign. All right, let's try that one. All right, so I said we had to do the tangent. Did we have a plus or a minus to begin with? Plus. I messed up on I shouldn't have written those parentheses. I'm sorry. Okay. All right, so I'm going to keep the sign on the top. I'm keeping the plus on the top. And then on the bottom, I'm going to do 1 minus. Okay, and I know I do tangent, tangent, tangent times tangent. Okay, so what number am I plopping in first? 7 pi over 6 goes in the first spot, and then what's going in the second spots? Pi over 4. Notice I just plopped it into both spots kind of at the same time. All right, now we're back to good old unit circle. Oh, that's a little trickier though, isn't it? Okay, because now I'm doing tangent off of unit circle, and that means I've got to do the sine divided by the cosine. Okay. All right, so let's talk about sine divided by cosine for 7 pi over 6. So what's the sine of 7 pi over 6? Negative 1/2. Okay, what's the cosine of 7 pi over 6? Negative square root of 3 over 2. What's going to happen with the double negative? Positive. What was our other shortcut?
You can take out the 2's.
You could take out the 2's. So you get 1 over square root of 3.
Rationalize it.
Well, let's see. Let me see what we have to do here. I think I did rationalize it before, so let's go ahead and rationalize it now rather than later. So square root of 3 over 3. Which, anytime we see 1 over square root of 3, we almost could automatically go, I know that's square root of 3 over 3. So I'm going to plop that square root of 3 over 3 in there, and in this first spot here. Okay? Now I need to calculate tangent of pi over 4. So I'm going to do the sine over the cosine. What's the sine of pi over 4? Square root of 2 over 2. What's the cosine of pi over 4? Do I even really need to write that one down? What's the tangent of pi over 4? 1. Okay. So, let's see what we can do with that one. Let's see what I can do to combine my like terms. So I'm going to try to combine my numerator, my denominators, at least in that spot. I'm going to turn this 1 into 3 over 3. So on the top, I've got square root of 3 plus 3 over 3. I'm going to do kind of the same thing here. I've got 3 over 3 for that one. So I've got 3 minus square root of 3 over 3. What do you notice?
It cancels out and equals.
What cancels out? What's our shortcut? The denominators would cancel, right? We're gonna, even though it's not on the trig, that shortcut still works for us, right? Because we know we would flip and multiply and those denominators would cancel. All right. That's probably not going to be the answer you see in the book. Why? It's not rationalized. There's a radical in the denominator. How do I rationalize something like that?
You do the conjugate.
You multiply by the conjugate. Good. All right. In the numerator, it's going to be FOIL, right? Because I'm going to have to use FOIL up there. In the denominator, I'm only going to use first and last. Okay? So let's try that. And I know this one's getting long. All right. So what's square root of 3 times 3? 3 square root of 3. Okay, square root of 3 times square root of 3 is 3. 3 times 3 is 9, and 3 times square root of 3 is 3 square root of 3. All right, we'll come back to that in a minute. On the denominator, we're just going to do first and last. So it's 3 times 3. 9, and negative square root of 3 times positive square root of 3 is negative 3. Okay, I'm going to try to squish in as much as I can here. What is 3 plus 9 right here? 12. All right, this square root, remember, acts like an x. So we're going to just add the coefficients in front. So what's 3 plus 3? 6 square root of 3 all over what? 6. Okay, I'm going to do something a little bit tricky. Couldn't I write that as 2 separate fractions? Yeah. I'm going to just split it there because rather than writing another whole line to do that. Okay. And then what's 12 over 6 reduced to? 2. And what happens with the 6's here? So plus square root of 3. That's my final answer on that one. And I know example 3 was really long. It's just that's the way that one is. Okay. It's not that it's tedious, right? It's not that these are hard. It's all plugging and chugging into a formula. But we've got, they're tedious. And there's no way around the tedious. But we're going to skip example 4. Okay? The next one's only 2 lines. Okay? So that's good news, right? And I'm only going to go to example 7 today.
What?
Okay? So we're going to stop at example 7. Alright. So, we're going to write the expression is the sine, cosine, or tangent of the angle. So here's what I need you to do. I need you to go back and look at those sum and difference formulas. And if you've already missed them on the, whatchamacallit, we've already flipped the page on the notes, look inside the front cover of your book. They're on the bottom left-hand column of that front inside cover. Do you see them? Sum and difference formulas at the bottom left? All right. So we have sine, cosine, cosine, sine. So what is that? Is that sine, cosine, or tangent? Sine. And then what we do is we take our two angle measures and write them in there. And should this operational symbol be a plus or a minus? Plus. So sine, we always keep it, right? And then I write 110 and 80. And then could I add those two numbers up?
Yeah.
So sine of 190 degrees. That's all they're asking us to do on that one. All right, let's look at the next one. The next one looks really awful, but it's not as bad as it seems. All right, which one is that one? Is that a sine, a cosine, or a tangent? Better be a tangent, right? We shouldn't have to think about the tangent one. All right, so we know it's a tangent. And what should the operational symbol be? Subtract, whatever's on the top, right? And then I'm going to plot my two angle measures in there. So 154 minus 49. And then evaluate that. What's 154 minus 49? 105 degrees. So basically they're working the formulas backwards on those two. All right. Looking at example 7. Okay, a little bit uglier. Because we've got radian measure. Is that one sine, cosine, or tangent? Sine again, good. Sine, and what operational symbol am I going to put in the middle? Plus, I get to keep it, right? All right, and then I'm going to plop in 4 pi over 9 and pi over 8. Definitely not something that we would read off our unit circle, okay? I do need to, if I'm going to simplify that, I'm going to have to do fraction work, right? So sine, what's going to be our common denominator here? 72, I like. Good. Okay. So what do I have to multiply the 4 pi by? 8. So 8 times 4 pi is going to be what? 32. Good. And what am I going to have to multiply the pi by? 9. So you get 9 pi. So what's 32 pi plus 9 pi?
41 pi.
41 pi over 72. Unfortunately, the first ones we did, the first 3 examples are more common and probably more likely what you're going to see on the test. There might be one of these where it works it backwards, but it's more common to see it the other direction. Okay? All right, that's where I'm going to stop. All right, I know I didn't stamp homework yesterday, so I know I need to come around and do that. Right? I've got a little bit of time left to do that. Good news, your books are already on the table. You could open that up and get some homework done, right? So why don't we do that right now? Okay, so you guys get going on that. I'll be